case where a uniform mass rod, where the mass distribution is uniform, this is pivoted over here, and so that it is free to rotate in the vertical circle. This is free to oscillate also in the vertical circle. And these are two springs with spring constant K1 and K2. They are perfectly horizontal. Length is now natural. There is no extension or compression in these springs right now. This is vertically hanging. We have to find, if we displace by small theta, if we displace it slightly, then what is going to be the time period for the small oscillations. Once again, we are using the term small oscillations. As we know, sine theta is equal to theta only for the very small values of theta. So the first step, as usual, what we are doing is displace it by small angle theta. So we displace it by a small angle theta. This was even displaced over here, right? So this angle is theta. From here to here is L by 2, from here to here is L. So as soon as we displace it, so we come to the second one, find restoring torque. So to find the restoring torque, and we know torque is force into perpendicular distance between line of force and acceleration. So first is we have to find the forces which will create torques which will try to bring back the body to its original mean position. So over here, one is mg. This has also come into play. Earlier this was passing, this mg was passing through the line, this line of force was passing through the axis of rotation only. So that's why there was no torque. Once it has been displaced over here, so now mg is effective and it will create torque which will try to move it this way. Similarly, there is some extension in this. Let's call it as x1. And this is so small that this will still remain horizontal only, so we don't have to break into components. So this is x1, and similarly for this also it is x2. Spring of K2 is x2. This is also remains horizontal only, right? So if we take torques about O, let's talk about torque about O. Torque of mg about O is force into perpendicular distance between line of force and acceleration. So this is the line of force. This is L by 2. So this is L by 2 cos theta, and from here to here this is L by 2 sin theta. Line of force and acceleration, the distance is L by 2 sin theta. So torque is force into perpendicular distance between line of force and acceleration, that is L by 2 sin theta. This is torque of this thing is done. Of this one. Now extension is x1. So the force which is generated is K1 into x1. So torque of this force, that is K1 into x1, force into perpendicular distance between line of force, this is line of force, this is accelerated rotation, and what is this? This is L by 2. So this is L by 2. So this is torque of this force. Because of extension there is some force, because of this force there is torque about O, and that is force into perpendicular distance between line of force and acceleration, that is L by 2. Plus, now over here we see that this string is stretched. If this string is stretched, this will try to pull it in this direction. That is, this force will try to create a clockwise movements. Similarly, when we move this from here to here, this spring gets compressed. When this spring gets compressed, this will apply a force in this direction. So that's why it will contribute once again towards the clockwise movements. So the torque of this force, what is the force? That is K2 into x2. x2 is the compression in this. So the force is K2 into x2. Force into perpendicular distance between line of force, this is line of force, this is accelerated rotation, so this is L, right? This theta is so small that is almost all the forces, they are perpendicular only. Also, we understand that is, this is, the whole rod is rotating about O. As a result, when this is rotating about O, so this point is moving in a circle of radius L by 2, whereas this end is moving in a circle of radius L. So x1, that is length of arc, S is equal to r theta. We are using S is equal to r theta. So this x, length of the arc, which is almost a straight line, x1 is equal to L by 2 into theta. Whereas this x2, this arc, which is almost a straight line because theta is very small, so x2 is going to be S is equal to r theta. So x2 is going to be, it is moving in a circle of radius L. So x2 is equal to L into theta. So we have x1 is equal to L by 2 theta and x2 is equal to L theta. We can put it over here. So we can get, that is torque about O is going to be mg into L by 2 into sine theta is equal to theta. We can taking this theta is very small. So sine theta is equal to theta plus K1 into x1. x1 is what? L by 2 theta. K1 x1 into L by 2 plus K2 into x2 is what? x2 is L theta into L. This is torque. torque is equal to I alpha. This is net torque is equal to I alpha. So we can once again, we can put it as equal to ml square by 3, we can make it a capital L, so ml square by 3 into alpha, torque is equal to I alpha. We have found the torque about this axis, so I should also be about this axis. We know that is moment of inertia of thin rod where the mass distribution is uniform about an axis passing through one of its ends and perpendicular to its length is ml square by 3. So torque is equal to I into alpha. So from here we see that is theta can be taken out, ml square by 3 can come over here. So if we rearrange, we can directly see, if we are not much bothered about what is the answer we get, but we are more bothered that is how we proceed. So alpha will come out to be something into theta. Theta can be taken out from all these terms, theta can be taken out, and this will come in the denominator. So alpha is equal to theta. So also we can see that is alpha is, if we remove this equality sign, so alpha is proportional to theta. Also, when we move it from here to here, all the torques, be it of this, be it of this force, be it of mg, all the torque, restoring torque is in this direction. Net torque is in this direction. It may happen that some of the torques, even if they are in the opposite direction also, but we have to find the net torque. Net torque is in this direction and theta had been in this direction. The direction of net torque and net alpha will be in this direction and theta is in this direction, so they are opposite directed. So we can say alpha is proportional to minus theta. If alpha is proportional to minus theta, so it means this condition is met. If this condition is met, t is equal to 2 pi theta by alpha. So t is equal to 2 pi theta by alpha. You can rearrange and get the value of theta by alpha and you can put it over here. T is equal to 2 pi theta by alpha and you can get the time period once again for very small values of theta and for very small value of amplitudes. So you get the time period for very small values of theta only. If the theta is large, then this formula will not hold good.